So this is Lower 6 Mechanics, Chapter 10, F, Question 4. I just thought I'd also do one, I'd model one where we've got the pulley sort of on the end of a table. So let's get the diagram sorted first of all. So we've got we've got A on top of the table with a mass of 5g, so that's got a weight of 5g, and obviously a normal reaction of R because that block isn't sinking into the table or going up into the air. Now again, similar to with the question 2, just get into the routine of either side of the pulley having the two tensions with the arrows pointed towards each other being equal and opposite, both sides of the pulley. And again, just mentally, just sort of break it down there, do a dotted line there and a dotted line there, so that if we want to, we can just look at A in isolation up here and B in isolation down here. Now this is again a classic question where we're going to be asked to work out the acceleration and the tension, and really you're doing the two together. So what we're going to do, we're going to resolve from the point of view of A horizontally, and we're going to resolve from the point of B vertically. Both of them are going to generate an equation that have got T and A as unknowns, and then we're going to have two unknowns, two equations, and then we can just solve this simultaneous equation. Now both of these equations, again, our starting point is F equals ma. So let's look at A first of all, and we're resolving in the direction of motion, which is left to right. So F, what is our net force? Well, the two forces involved horizontally are the tension and the 24.5 friction. Now obviously the tension wins because we're moving left to right, so T minus 24.5 is our net force, and that equals our mass of 5 times our unknown acceleration. Now moving on to B, we're now going to resolve again in the direction of motion, which is downwards. Now the two forces involved are the weight, which is 3g, and the tension. The 3g wins because we're moving downwards, so 3g must be bigger than t. So 3g take away t equals 3a. So we've got our two equations here. Now you could just go and make the t the subject of one of them and substitute it into the other. That's absolutely fine. But what you'll find when you get into the habit of these, one of them always has a plus t and the other has a minus t. So in a way, the easiest way to eliminate one of them first of all is just to choose to add the two equations together, which will get rid of t because t minus t disappears. So what are we left with if we add these two equations together? Well, on the left hand side we're left with 3g and a minus 24.5, and on the right we're left with 8a when we add them together. So A is now our only unknown because of course g is gravity, so we can just work out that the acceleration is 0.6125. Now for part B we've done all the hard work really. We've worked out what the acceleration is, and this is the second part of any simultaneous equation. You've just got to substitute that back in to either of the equations to work out the other unknown. So I've chosen the top equation for A. So t minus 24.5 equals 5a. We've just worked out the acceleration is 0.6125. So just process the algebra and we get the tension being 27.6 newtons. Now I think part C is okay once you've actually done one or two of them. You can see what's going on. So just imagine you're the pulley and you're being really pulled to the left by the tension and pulled down by the tension. What is that overall force on you? So you're being pulled to the left by the tension of 27.6 and you're being pulled downwards by 27.6. Well, the net effect is this force here, and you can kind of feel it. If you were the pulley and suddenly you came off the mechanism holding you there, you'd sort of shoot in that direction, wouldn't you? Because you're being pulled left and down. So we actually just have a situation where we've just got Pythagoras here. So our force is 27.6 squared 27.6 squared square rooted, and that gives us 39.0 newtons.